Hey students, this is your second video lesson. This is investigation 2, parallel lines cut by a transversal. You should know right away that when you cut parallel lines by transversal, there's a bunch of special relationships between the angles, and we'll discover some of those, and you'll get some of those by definition. Here's an example of two parallel lines cut by a transversal. Notice the transversal is T. So it's a line that goes across the two parallel lines. That's the transversal. When you do that, you get 8 angles created, and there are some special relationships. Some of them you may just look at right now and try and figure out. Go ahead and pause the video if you want. And try and figure out. Some of those angles are actually equal. Well, of course, there's the vertical angles like we learned about, but there's some other angles between the two sets. Like there's some angles from this oval up here that are going to be congruent to some of those as long as these two lines are parallel. And we show they're parallel by usually putting an extra arrow on those, like that. So I'd like to add one more definition to this. And that is, and the other definitions will come up in the lesson, but angles like 1 here and 5 here, notice they're in the same position. They're both on top of the parallel line and on the same side of the transversal. Angle pairs like that, like 1 and 5, are called corresponding angles. Another pair of corresponding angles is 2 and 6. 4 and 8 are corresponding angles. And there's one other pair. I'll let you try and figure out what the last pair of corresponding angles on that diagram is. All right? So, when parallel lines are intersected by a third line, the third line is called a transversal. When a transversal intersects parallel lines, there's a special relationship. We're going to try and discover those now. I'm going to take a protractor and I'm going to measure angles 1, 3, 5, and 7. And see if you don't notice anything about that. So I'm going to insert a protractor. There it is. And I'm going to place that protractor right at angle 5. And if you see this arrow, you see that it's pointing to right here at 140. So angle 5 is 140. I'm going to move that protractor, well, maybe I'll just move the drawing to angle 1, and now you can see that angle 1 is right here, same spot, 140. I'm going to change the protractor so I can measure angle 3. So I'm going to turn it upside down. And you should notice that angle 3 is right there. Actually, this one goes from here to here, which is 40 degrees. And I have one more to measure. That would be angle 7. And angle 7 is also, you'll notice it goes from there to there, which is 40 degrees. All right, so now we have those angles measured. So 1 is 140, 2 is 40, or 3 is 40, 5 is 140, and 7 is 40 degrees. Some of you are probably thinking, well, if I knew 1 was 140, then I knew 3 was 40 because they're supplementary angles. They make a straight line. Same with 5 and 7. So, which pairs of angles appear to be equal? It seems like angle 1 and angle 5 are the same. And also angle 3 and angle 7. Let's write it this way. Angle 1 equals angle 5. Angle 3 equals angle 7. And if you remember from earlier in the lesson, those are corresponding angles. And it is true. Corresponding angles are equal when you have two parallel lines cut by a transversal. So I'm going to write that right now. Corresponding angles are equal. All right, the second part of this says which pairs of angles appear to be supplementary. And we can see that angle 5 plus angle 7 equals 180, which means angle 5 and angle 7 are supplementary. And we can also see that angle 1 plus angle 3 are supplementary. Also, you can mix them up a little bit, and you might notice that angle 3 together with angle 5, those are supplementary angles. So angle 3 plus angle 5 equals 180. Another pair of supplementary angles. And angle 1 plus angle 7 equals 180. Another pair of supplementary angles. Okay. The pair of angles like 4 and 6, those are supplementary, and those are called the same side interior angles. And we'll talk a little bit more about why they're called that. All right. Number 2, why does angle 3 equal angle 2? Let me erase all the stuff from the drawing there. Angle 3 and angle 2 are equal, and I'm sure you know this because they are vertical angles, and vertical angles are equal. So the answer to that question is because they're vertical angles. Then it says, does angle 7 equal angle 2? And I think it does because we know that from the last problem that angle 3 and angle 7 are equal. So we already have angle 3 is equal to angle 7. And we have angle 3 is equal to angle 2. And so if angle 3 is equal to angle 7 and angle 3 is equal to angle 2, then that means angle 7 is equal to angle 2. And the property I just used to do that is called the transitive property. If A is equal to B and B is equal to C, then A is equal to C. Use the same line of reasoning as in exercise 2 to show why angle 1 is equal to angle 8. I think we'll do this in class. Let you do that, but you can use the same idea. The angles that are created on the opposite sides of a transversal inside parallel lines are called alternate interior angles. Alternate interior angles are the angles on the alternate exterior angles are the angles on the outside of the parallel line. Just move this down. Let's make a quick diagram so you can see this. There's my parallel lines. There's my transversal. Alternate interior angles are like these two angles right here. Those are alternate interior angles in blue. Alternate interior angles. And I'm going to mark in red. There's another set of alternate interior angles. You can probably see them. In red, I'm going to mark alternate exterior angles. This one here, and this one here. So in red, we have alternate exterior angles. And they're called that because between the two parallel lines is known as the interior, and outside of the parallel lines, that area is known as the exterior. And this is the exterior also. All right, so let's do some work with that stuff. What can you say about the measures of alternate exterior angles when two parallel lines are cut by a transversal? So alternate exterior angles. I'll just make a quick drawing. So we're talking about like A and B are alternate exterior angles. What can we say about them? Well, we just found in the last problem that corresponding angles are equal. So that would mean something like, if I label this C, then we know B is equal to C. Angle B is equal to angle C because they're corresponding angles. And also we know C is equal to A because they're vertical angles. So I'll just write that they're corresponding angles. C is equal to A because they're vertical angles. And so because B is equal to C and C is equal to A, we can say that B is equal to A because they are, but that's called the transitive property. You don't have to know that, but it's something eventually you will have to know. So they're equal. Alternate exterior angles are equal. Alternate exterior angles are equal. All right, number 5, in exercise 1, you should have found that angle 1 and angle 5 appear to be equal. What conjecture can you make about angle 4 and angle 5? Use your knowledge of vertical angles. So I'm just going to quick redraw that. So I have it here. So, and if I go back and look at that original drawing, we need 1 and 5. 1 and 5, so it's 1, 2, okay. So 1 and 5 were equal because they are corresponding angles. Those are equal. So what we're wondering about is 4 and 5. 4 and 5 are alternate interior angles. And I think that they are congruent. They sure look the same. You match those up. Well, we know that 1 and 4 are the same because they're vertical. So we can say angle 1 is equal to angle 4 because they're vertical. And we can say angle 1 is equal to angle 5 because they are corresponding angles. And by the transitive property, then, we can say that angle 4 is equal to angle 5. Because angle 1 is equal to angle 4, and angle 4 is equal to angle 5, so angle 4 must equal angle 5. That's the transitive property. This is going to be the end of part 1. You can view part 2 to finish the rest of the problem.